In this lesson, we're going to be working with similar triangles here. So our goals are that by the end of this lesson, we should be able to recognize when two triangles are similar and use the fact that two triangles are similar to solve for the sizes of unknown sides and unknown angles. So in a previous lesson, we talked about congruent triangles. We said that congruent triangles were the same shape and that they were the same size. They were the same shape because their corresponding angles were the same, and they were the same size because their corresponding sides were the same. And we showed this picture of two congruent triangles. Similar triangles have the same shape, but they are not the same size. So here's an example of two similar triangles. They are the same shape, which means that corresponding angles are the same size. So when we look at these two triangles here, we can see that angle D is equal to angle P. We can see that angle E is equal to angle Q. And we can see that angle F is equal to angle R. They're both right angles. So corresponding angles between the two triangles are the same, but corresponding sides are not the same length. Obviously, the length of side DF is much smaller than the length of side PR, which is the corresponding side. Instead, in similar triangles, corresponding sides are proportional to each other. So what do we mean by corresponding sides are proportional? We mean that if we took the ratio of the length of side DE to the length of side, what's the corresponding side PQ, because those are corresponding, it would be the same as the ratio of the length of side DF and its corresponding side PR. So notice I'm setting this up that I'm putting all of the sides from my small triangle in the top and my large triangle, I'm putting them all down in the bottom. So this ratio would be the same if we were to compare what's our third side here. EF from our small triangle, which corresponds to side QR in our large triangle. So this is sort of the key skill of working with similar triangles, is be able to figure out what are the corresponding sides. We know that DE and PQ are corresponding sides because DE goes from the two arcs, the angle with two arcs, to the angle with one. Same thing for angle PQ. Similarly, side DF and side PR are corresponding because they go from the two arc angle to the right angle. And if we've matched up two of them, we know that the third one has to be corresponding as well. So if we know this, that the sides are proportional to each other, we can say that the triangles are similar. So we can say that triangle DEF is similar to triangle PQR. And that little squiggle in the middle just means similar. There are three ways of showing that two triangles are similar. We can, just like with congruent triangles, we can show that we have like the SSS method. We can show that three pairs of corresponding sides are proportional. We have the side angle side method. We can show that two pairs of corresponding sides are proportional and the contained angle is the same. And we have the angle angle method. Two pairs of corresponding angles are the same. This automatically means that the third angle in each triangle is going to be the same as well, because the angles have to add up to 180 degrees. So looking at this first triangle, these two triangles here, ABC and DEF, we can kind of see which sides, just by the shape, which sides are our corresponding sides. Looks like this side and this side are corresponding, this side and this side are corresponding, and this side and this side are corresponding. So when we look at the lengths of corresponding sides, AB over DE, AB has a length of 20 and DE has a length of 40. So the ratio of those sides is 1/2. We should get this same ratio if the triangles are in fact similar. We should get the same ratio between our other pairs of corresponding sides. So in fact, if we do BC divided by EF BC is 43, EF is 86. Again, we get 1/2. And for our third pair, we've got AC and DF. AC is 30, DF is 60. Again, we get 1/2. So we can use side, side, side to say that triangle ABC is similar to triangle DEF. We take a look at another example here. We've got triangle PQR and RST. We aren't given the lengths of any sides or any angles in these two triangles, but we can use our angle properties to kind of figure out what's going on. We know that this angle here and this angle here are going to be the same because they are opposite angles. And because PQ and ST are parallel to each other, we could draw like a little Z pattern. Okay? Then we know that this angle here, P, and this angle T are going to be equal to each other. Once two angles are the same, we know that the third angle is going to be the same in each one as well. So we have three pairs of angles here that are all the same size. That's enough to show using angle-angle property that these two triangles are similar. So we could say that triangle PQR is similar to triangle T, which matches up to angle P, T, S, and Q. Q matches up to side S. T, oh wait, TS, sorry, R, because clearly angle R and angle R match up to each other. All right.